Hello, in this lecture we will find out the area of a circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have a circle. In addition, we know that side AB of this quadrilateral equals to 2 units in its length. Side BC equals to 8 units. Side DC also equals to 8 units in its length. In addition, this is angle ABC that is equals to 90 degrees in its size, and this is angle DCB that is also a right angle. It is equals to 90 degrees in its size. Again, our mission is to find out the area of this circle. So first of all, we will do a construction. That is to say, we will extend side DA and side CB of this quadrilateral by a straight line until they touch each other. So this is their touching point. We define the touching point of the extended side DA and the extended side CB is point M. We define this angle as theta. Actually, by doing this construction, we created the right triangle DCM. In this right triangle DCM, this angle equals to 90 degrees, this angle equals to theta, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended the straight line BC by a straight line, and the result is CM. When you extend a straight line by a straight line, the result must be a straight line. So CM is one straight line. If you focus on the upper side of this straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that's equal to 90 degrees plus the missing angle that is actually angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here, angle ABM, the missing angle ABM must be equal to 90 degrees in its size. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees. And therefore, triangle ABM is a right triangle. We focus on this small right triangle ABM. In the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. So I write it down. In the next step, we will prove that the right big triangle DCM, is similar to the right small triangle, this right small triangle MBA. So I write it down. The right big triangle DCM is similar to this right small triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle DCM in triangle DCM, and it is equal to this angle, that is actually angle ABM, in triangle MBA. Repeat again. Angle DCM in triangle DCM equals to angle ABM in triangle MBA, the small triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles. So we can write that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to this angle theta, as it belongs to the right big triangle DCM, it will be called angle DMC. And if we relate to angle theta as it belongs to the right small triangle MBA, it will be called angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MDC in triangle DCM, and it is equal to this angle, that is actually angle MAB in triangle MBA, repeat again, angle MDC equals to, in triangle DCM equals to angle MAB in triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right big triangle DCM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, the right big triangle DCM is similar, this is the sign of similar, to the right big triangle MBA, according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. That side DC in the big right triangle DCM over side AB in the small right triangle MBA equals to side CM in the big right triangle DCM over side BM in the small right triangle MBA. I repeat again. DC over AB equals to CM over BM. DC equals to 8 units in its length, according to what is given us the question here, over AB. AB equals to 2 units in its length, and it is also equals to CM. CM, this is side CM. From the drawing, it is very easy to see that CM in total equals to CB plus BM. That is to say, CM equals to CB, that is 8, plus BM. So in total, CM equals to 8 plus BM. So we substitute CM by 8 plus BM divided by BM. Repeat again. In conclusion, we found out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we will multiply this equation by BM, and we'll get that 4 times BM equals to 8 plus BM. Here we will subtract BM from this equation, and we will get that 4BM minus BM is 3BM equals to 8. So here we will divide this equation by 3, and finally we will get that BM equals to 8 over 3 units in its length. So line segment BM or side BM equals to 8 over 3 units in its length. So I write it down here in the drawing itself. BM equals to 8 over 3 units in its length. In the next step, we will implement the Pythagoras theorem on this small right triangle MBA. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle MBA is AM. Therefore, the square of the hypotenuse is AM squared, and it must be equal to AB squared plus BM squared. Repeat again. in the right triangle MBM, according to the Pythagoras theorem, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, is equals to AB squared. AB equals to 2, therefore AB squared is 2 squared, that is 4, plus BM squared. BM equals to 8 over 3, therefore BM squared is 8 over 3 squared, that is actually 64 over 9. So AM squared equals to, here we multiply 4 by 9 and then we divide it by 9 in order to have a common factor with 64 over 9. So 4 times 9 is 36. So in total, in the numerator we have 36 plus 64 over 9. 36 plus 64 is 100 divided by 9. So AM equals to 100 over 9. Here we will take a root out of this equation. And finally, we will get that AM equals to the square root of 100 over 9. The square root of 100 is 10 and the square root of 9 is 3. So in total, we found out that AM equals to 10 over 3 units in its length. The hypotenuse AM equals to 10 over 3 units. So I write it down. The length of the hypotenuse AM is 10 over 3 units. In the next step, we will do another construction. That is to say, we will draw perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. Okay? It is absolutely possible to do it because we can draw the perpendicular on BC on any point on BC. So we'll choose the point on BC in such a way that the perpendicular on BC will be also tangent to this circle. Okay? So you have here infinite points on BC that you can draw that perpendicular. Out of the infinite points, we definitely find the point that also makes a tangent to this circle. The perpendicular will be also tangent to the circle. So, first of all, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular inside CM as point T. We will define the point of tendency of this perpendicular with the circle as point K. In the next step, we will extend the perpendicular TK by a straight line until it touches side AD. And we will define the touching point of the extended perpendicular TK with side AD as point S. By doing this construction, we created here the right triangle STM. In the right triangle STM, this angle equals to theta. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. In the next step, we will define the center of this circle, this point as O. And we will define the point of tendency of tangent BT with this circle as H. And finally, we will define the point of tendency of tangent AB with this circle as N. In the next step, we will join points O and H together by a straight line. And we will define the radius of this circle as X. So here we have point O is the center of the circle. Point H is the point of the circle itself. This is exactly the definition of a radius. So OH is the radius of the circle that is equals to X according to our definition. We can implement here rule 1. I repeat quickly on rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the domain we have a circle, and also we have tangent AB that is tangent to this circle at point M. Point M is the point of tendency. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM that is drawn to point M. It is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to this rule, rule 1. We can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius OH that is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we will join points O and K together by a straight line. Line segment OK is the radius of this circle that is equal to X according to our definition. Again, we have the radius OK that is drawn to point K, therefore according to rule 1, this angle equals to 90 degrees, this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and N together by a straight line. Line segment ON is the radius of this circle that is equal to X. Again, we have the radius ON that is drawn to point N, therefore according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. We focus on the small quadrilateral OKHT. In this small quadrilateral OKHT, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the fourth angle In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral OKHT to 360 degrees, the missing angle here must be equal to 90 degrees in its size. So actually we found out that inside quadrilateral OKHT we have four right angles. Any quadrilateral that has four right angles must be at least a rectangle, if not a square. So we relate to quadrilateral OKHT as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle OKHT, side OK must be equal to the opposite side HT. But OK is x, therefore HT must be also equal to x. Likewise, according to the same rule, side OH must be equal to the opposite side KT in rectangle AH or KHT. Therefore, but OH is x, therefore KT is also x. So actually found out that quadrilateral OKHT, the small quadrilateral OKHT, is not a rectangle but a square. Why? Because all of its sides are equal to each other. We will repeat on the same process on this small quadrilateral NOBH. Inside this quadrilateral we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. It must be also a right angle. So inside quadrilateral NOBH we have four right angles. Therefore, we can relate to this quadrilateral with four right angles as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, side NO must be equal to the opposite side BH in rectangle NOBH. But NO is x, therefore BH must be also equal to x units in its length. Likewise, according to the same rule, in rectangle NOBH, side OH must be equal to side NB. But OH is x, therefore NB must be also equal to x units in its length. Again, we found out actually that quadrilateral NOBH is not a rectangle but a square because all of its sides are equal to each other. In conclusion, we actually found out that line segment BT in total equals to x plus x, that is 2x. So I write it down. We found out that line segment BT equals to 2x units in its length. In the next step, we will prove that the right if we relate to this triangle as the biggest triangle, if triangle DCM, we relate to it as the biggest triangle. Triangle STM will be the middle triangle, and triangle ABM will be the smallest triangle, the smallest right triangle. So we will prove that the middle triangle, triangle STM, is similar to the smallest triangle, triangle MBA. Repeat again, we will prove that the middle triangle, the middle right triangle STM is similar to the smallest triangle, triangle MBA. So why those two triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle STM. In the middle triangle STM, and it is equal to this angle that is actually angle ABM in the smallest triangle, triangle MBA. Repeat again. Angle STM equals to angle ABM. Angle STM in triangle STM equals to angle ABM in triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. So write it down. Again, if we relate to angle theta as it belongs to the middle triangle STM, it will be called or will be defined as angle SMT. And if we relate to the same angle theta as it belongs to the smallest triangle MBA, it will be defined as angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MST. In triangle STM, the middle triangle STM, and it is equals to this angle, this is actually angle MAB. In the smallest triangle, triangle MBA. Repeat again. Angle STM in the middle triangle STM, actually angle MST in the middle triangle STM equals to angle MAB in the smallest triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in this middle right triangle STM are correspondingly equal to all the three angles in the smallest triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The middle triangle STM is similar. Again, this is the sign of similar to the smallest triangle, triangle MBA. According to angle similarity rule. And from the fact that the middle triangle is similar to the smallest triangle, we will derive that the following relationship exists between their sides. We derive that side ST in the middle triangle STM over side AB in the smallest triangle MBA equals to side TM in the middle triangle STM over side BM in the smallest triangle MBA. Repeat again. So we derive that ST over AB equals to TM over BM. And also that the hypotenuse SM in the right triangle is TM, and it is equal also to the hypotenuse SM in the right triangle is TM over the hypotenuse AM of the smallest triangle MBA. Okay. So this equation is the relationship between the sides of the two similar triangles, the middle triangle STM and the smallest triangle MBA. So ST over B equals to ST over AB equals to TM over BM equals to SM over AM. Okay. Side ST is the missing side, so we will leave it as it is over AB. Here AB equals to 2 units instead, so we substitute AB by 2. And it is equals to side TM. What is the length of TM? From the drawing it is very easy to see that TM in total equals to TB plus BM. That is to say TM equals to TB, that is 2x, plus BM, that is 8 over 3. So in total TM equals to 2x plus 8 over 3. So we substitute TM here by 2x plus 8 over 3, and we have to divide it by BM. BM is 8 over 3. Here, BM is 8 over 3. And it is also equals to SM over AM. From the drawing it is very easy to see that SM, in total SM equals to side the hypotenuse SM of the middle triangle STM. In total it is equals to SA plus AM. So SA is the missing side, so we leave it as it is, plus AM, that is 10 over 3. So in total SM equals to SA plus 10 over 3. So we substitute SM in this equation by SA, that is the missing side, plus 10 over 3, divided by AM. Here AM equals to 10 over 3. So those two sides are equal to each other, therefore we'll create the equation, the first equation from those two sides that are equal to each other. So according to the first equation, ST over 2 equals to 2x plus 8 over 3 over 8 over 3. So here ST over 2 equals to, we have here 2x plus 8 over 3. We will multiply 2x by 3 and then we will divide it by 3 in order to have a common factor with 8 over 3. 2x times 3 is 6x. So in total, in the numerator, we will have 6x plus 8 divided by 3, and we have to divide it by 8 over 3. So in this side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. What is left from this equation the first equation after we cancel 3. In this side of the equation we left only with st over 2. That equals on the other side of the equation we left only with 6x plus 8 over 8. So here we'll cross multiply this equation, the first equation, and we get that 8 times st equals to 2 times 6x plus 8. So here we will divide this equation by 2. So according to equation 1, here 8 over 2 is 4. So in total, in this side of the equation, we will have 4 times st. On the other side of the equation, 2 over 2 is 1. So we left only with 6x plus 8. Here we will divide this equation by 4. And finally, we will get that st equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in conclusion, we found out that the length of line segment st is 1.5x plus 2. So I write it down in the problem itself that this line segment st or side st, in total it is equals to 1.5x plus 2. Okay. We will continue to focus on this long equation. In this long equation, we have those two sides, they are equal to each other. So we will create equation 2 from those two sides that are equal to each other. So according to equation 2, we have 2x plus 8 over 3 over 8 over 3 equals to SA plus 10 over 3 over 10 over 3. This is equation 2 that we created from the log equation. So in this side of the equation 2, we have 2x plus 8 over 3. Here we will multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. So 2x times 3 is 6x. So in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. And it is equals to, on the other side of the equation, we have SA plus 10 over 3. Here we multiply SA by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. SA times 3 is 3SA, so in total, in the numerator of this expression, we will have SA plus 10 divided by 3, and we have to divide it by 10 over 3. So in this side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. On the other side of the equation 2, we have 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. What is left on this equation after we cancel 3 from both sides of the equation. Equation 2. In this side of the equation 2, we left only with 6x plus 8 over 8. In the other side of the equation, we left with 3 times SA plus 10 divided by 10. So here we will cross multiply this equation, and you will get that according to equation 2, 10 times 6x plus 8 equals to 8 times 3SA plus 10. Here we'll divide this equation by 2. And finally, we get that according to equation 2, 10 over 2 is 5. So in total, in this side of the equation, we have 5. Inside the brackets, we have 6x plus 8 equals to, the other side of the equation, we have 8 over 2 is 4. So in total, in this side of the equation, we have 4. Inside the brackets, we have 3SA plus 10. Here, we will open the brackets on both sides of this equation, equation 2. And we get that according to equation 2, 5 times 6x is 30x, plus 5 times 8 is 40. That equals to 4 times 3SA is 12SA, plus 4 times 10 is 40. So this in this equation 2, we have 40 on both sides of the equation, so 40 will get cancelled. After we cancelled 40, we left only with 30x, that is equals to 12SA. So here we'll divide this equation by 12, and finally we'll get that SA equals to 30x over 12 is 2.5x. So if we found out that the length of line segment SA is 2.5x. So I write it down. Here, the length of this line segment SA is 2.5x. So I write it here. In the next step, I will copy the small quadrilateral ASBT with the circle that is inscribed inside it, and we will analyze this quadrilateral ASBT. So actually, this is quadrilateral ASBT with the circle that is inscribed inside it, that I copied from the original drawing. So first of all, we define the point of tendency of tangent AS with this circle as K. We define the point of tendency of tangent AB with this circle as N. We define the point of tendency of tangent ST with this circle as G. And finally, we define the point of tendency of tangent BT with this circle as H. Actually, we can implement in this drawing rule 2. I repeat quickly on rule 2. So according to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing we have a circle and we have the common standpoint point P. From the common standpoint point P we have two tangents to this circle, tangent PA and tangent PB. And according to rule 2, this rule, they are equal to each other. That is to say, PA equals to PB, or the length of tangent PA equals to the length of tangent PB. We can actually implement rule 2 in our drawing. Why? Because if you focus on the common standpoint point A, from the common standpoint point A, we have two tangents to this circle, tangent AN and tangent AK. And according to rule 2, they are equal to each other. That is to say, AN equals to AK. AN equals to AK according to rule 2. So if we define the length of this tangent AN as A, then the length of tangent AK must be also equal to A because they are equal to each other. So in conclusion, we found out that AN equals to AK equals to A. Likewise, we'll focus on the common standpoint point B. From the common external point, point B, we have two tangents to this circle, tangent BN and tangent BH. And according to rule 2, they are equal to each other. So BN equals to BH according to rule 2. So if we define the length of tangent BN as B, then the length of tangent BH will be also equal to B units, because they are equal to each other. In conclusion, we found out that BN equals to BH equals to B in the next step. We'll focus on the common external point, point T. From the common external point, point T, we have two tangents to this circle, tangent TG and tangent TH, and according to rule 2, they are equal to each other. That is to say, TG equals to TH according to rule 2. So if we define the length of tangent TG as C, or TG equals to 3 units in its length according to our definition, then tangent TH must be also equal to 3 units in its length, because they are equal to each other. So if we're going further, the TG equals to TH equals to C, and finally we focus on the common external point, point S. From the common external point, point S, we have two tangents to this circle, tangent TG and tangent TS, tangent SG and tangent SK. And according to rule 2, they are equal to each other. That is to say, SG equals to SK. SG equals to SK according to the same rule, rule 2. So if we define the length of tangent SG as D, then the length of tangent SK must be also equal to D, because they are equal to each other. So in conclusion, we found out that SG equals to SK equals to D. In the next step, we will join side AB to side ST. In this quadrilateral ASBT. Again, we join side AB to side ST. From the drawing, it is very easy to see that the length of side AB is A plus B. So AB equals to A plus B plus ST. It is very easy to see from the drawing that ST equals to C plus D. So it is plus C plus D. So in total, we found out that AB plus ST, in total it is equals to A plus B plus C plus D. Likewise, we'll join side AS to side BT. AS plus BT. from the drawing it is very easy to see that AS plus BT in total it is equals to A plus B plus C plus D. Again, AS plus BT equals to A plus B plus C plus D. So write it down. AS plus BT equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. So write it down. Actually found out that those two expressions, they are equal to each other. That is to say, AB plus ST equals to AS plus BT. Repeat again. Actually found out that AB plus ST equals to AS plus BT. AB equals to 2 units. AB equals to 2 units. So we substitute AB by 2 plus ST. This is 9 segment ST. This equals to 1.5x plus 2, or 2 plus 1.5x. So we substitute ST by 2 plus 1.5x. And it is equals to AS. From drawing it is very easy to see that AS equals to 2.5x. Okay, so we substitute AS in this equation by 2.5x. Plus BT. Here, BT equals to x plus x, that is 2x. So we substitute BT in this equation by 2x. In conclusion, found out that AB plus ST that equals to AS plus BT. It is actually 2 plus 2 plus 1.5x, that is equals to 2.5x plus 2x. 2 plus 2 is 4, so in total in this side of the equation we have 4 plus 1.5x. That is equals to, in the other side of the equation we have 2.5x plus 2x is 4.5x. So 4 plus 1.5x equals to 4.5x. Here we'll subtract 1.5x from this equation, and we get that 4 equals to 4.5x minus 1.5x is 3x. So 3x equals to 4. Here we divide this equation by 3, and finally we get that x equals to 4 over 3 units in itself. Again, x equals to 4 over 3 units. That is to say, the radius x of this circle equals to 4 over 3 units in its length. Again, our mission is to find out the area of this circle. The area of any circle equals to pi times the radius of the circle squared. So the area of this circle will be equal to pi times the radius squared. The radius is x, so it is pi times x squared. The radius squared is x squared. And we just right now found out that x equals to 4 over 3 units in its length. If x is 4 over 3, it means that x squared is 4 over 3 squared. So the area will be equal to pi, and x squared is 4 over 3 squared. So the area of the circle in total is equals to pi times 4 over 3 squared. 4 over 3 squared is 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, we found out that the area of this circle equals to either 16 pi over 9 square units, 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, this is the answer to the question. So in the next step, I will summarize the lecture. In this lecture, we found the area of this circle. Okay, again, in this lecture we found out the area of this circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral ABCD, we have this circle. In addition, we know that side AB of this quadrilateral equals to 2 units, side BC equals to 8 units, and side DC also equals to 8 units. This is angle ABC that is equal to 90 degrees. And this is angle DCB that is also equals to 90 degrees in size. Again, our mission is to find out the area of the circle. In order to find out the area of the circle, we did a construction. That is to say, we extended side DA inside CB of this quadrilateral by a straight line until they touch each other. This is their touching point. So we define the touching point of the extended side DA inside CB as M. By doing this construction, we created here the right big triangle DCM. We define this angle as theta. So inside the right triangle DCM, this angle equals to theta according to our definition. This is the right angle according to what is given as the equation. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So then we know that side CB is one side of this quadrilateral ABCD, therefore it is absolutely a straight line. Then when you extended the straight line CB by straight line, the result is CM. When you extend the straight line by straight line, the result must be a straight line. Therefore CM is a straight line. So if you focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is the right angle plus the missing angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on this right angle, in order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees. So if this angle is 90 degrees, it means that triangle ABM is a right triangle. So in the right triangle ABM, you have this angle that is theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Okay, so the sum rule, of course, that the sum of the angles in any triangle is equal to 180 degrees. Then we proved that the big right triangle DCM is similar to the small right triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, That is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself. It's a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we should prove that all the three angles in the right big triangle DCM are correspondingly equal to the three angles of the small right triangle MBA. Therefore, those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive the side DC of the big right triangle DCM over side AB of the small right triangle MBA equals to side CM of the big right triangle DCM over side BM of the small right triangle MBA. Read again. We derive that DC over AB equals to CM over BM. DC is 8, AB is 2, and what is the graph of CM? From a drawing, it is very easy to see that CM in total equals to CB plus BM. That is to say, CM equals to CB, that is 8, plus BM, that is the missing side. So in total, CM equals to 8 plus BM. It again. CM equals to 8 plus BM, and we have to divide it by BM. So you can only find out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM, we found out that 4 times BM equals to 8 plus BM. Here we subtracted BM from this equation, and found out that 4BM minus BM is 3BM, so 3BM equals to 8. Here we divided this equation by 3 and found out that BM equals to 8 over 3 units in its length. Here this side BM, line 7BM equals to 8 over 3 units in its length. Then we focus on this right small triangle MBA, and we implemented the Pythagoras theorem on this right small triangle MBA. According to the Pythagoras theorem, in this small right triangle MBA, AM square equals to AB square plus BM square. Again, AM square equals to AB square plus BM square. So AM square, that is the square of the hypotenuse, equals to AB square. AB is 2, therefore AB square is 2 square, that is 4, plus BM square. BM is 8 over 3, therefore BM square is 8 over 3 square, that is 64 over 9. So AM square equals to, here we multiplied 4 by 9 and then we divided by 9 in order to overcome a factor with 64 over 9. 9 times 4 is 36, so in total, in the numerator of this expression, we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So AM square equals to 100 over 9. We took a root out of this equation, and finally found out that AM equals to the square root of 100 over 9. The square root of 100 over 9 is actually the square root of 100, that is 10, over the square root of 9, that is 3. So in conclusion, we found out that AM, the hypotenuse AM equals to 10 over 3 units in its length. The hypotenuse AM equals to 10 over 3 units in its length. Then we did another construction. That is to say, we drew perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. Okay? So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular inside BC as T. We define the point of tendency of the perpendicular with this circle as K. We extended the perpendicular TK until it touches side DA at point S. We define the touching point as point S. By doing this construction, we created the right triangle STM. In the right triangle STM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Okay, then we define the center of this circle as O. we define the radius of this circle as x. We join points O and H together by a straight line. OH is the radius of this circle that is equal to x. We have the radius OH that is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule 1. Then we join points O and N together by a straight line. ON is the radius of this circle that is equal to x. The radius ON is drawn to point N, therefore according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and K together by a straight line. OK is the radius of this circle that is equal to x. We have the radius OK that is drawn to point K, therefore according to 1, this angle equals to 90 degrees and this angle equals to 90 degrees. We focus on this small quadrilateral OKHT. This small quadrilateral, we have 1, 2, 3 degrees, therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral OKHT, we have 4 right angles. Therefore, we can relate to quadrilateral OKHT as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side OK equals to side HT. But OK is x, therefore HT must be also equal to x. Likewise, according to the sum rule, OH must be equal to the opposite side KT in rectangle OK, HT. But OK is x, therefore KT must be also equal to x. So actually found out that quadrilateral OKHT is not a rectangle, but a square. We repeated on the same process on this quadrilateral NOBH. In this quadrilateral NOBH, we have 1, 2, 3 degrees, therefore the fourth angle must be also equal to 90 degrees, therefore inside quadrilateral NOBH we have 4 angles, therefore we can relate to this quadrilateral that is 4 angles is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side NO must be equal to side BH. But NO is x, therefore BH must be also equal to x. Likewise, side OH must be equal to side NB. But OH is x, therefore NB must be also equal to x. So, quadrilateral NOBH is not a rectangle, but a square. In conclusion, found out that BT equals to x plus x, that is 2x. Repeat again, BT equals to 2x units in its length. Then we proved that the middle right triangle STM is similar to the smallest right triangle, triangle ABM. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right triangle STM are corresponding equal to all the three angles of the smallest right triangle, triangle ABM. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that ST over AB equals to TM over BM equals to SM over AM. ST is the missing side, so we will leave it as it is, over AB. AB is 2, and it equals to TM. What is the length of TM? In total, TM equals to 2x plus 8 over 3. TM equals to 2x plus 8 over 3 over BM. BM is 8 over 3. Here, BM is 8 over 3. And it is also equals to SM. What is the length of SM? From the drawing, it is very easy to see that SM equals to SA plus 10 over 3. Okay, yeah. SM equals to SA plus 10 over 3 over AM. AM equals to 10 over 3. Here, AM equals to 10 over 3. So, we created this non-equation. Those two sides, they are equal to each other, therefore we created the first equation for those two sides that are equal to each other. So according to the first equation, ST over 2 equals to 2x plus 8 over 3 over 8 over 3. Here we multiplied 2x by 3 and then we divided by 3 in order to have a common factor with 8 over 3. So in this side of the equation we have 2x times 3 is 6x. So in total, in the numerator of this expression, we have 6x plus 8 divided by 3, and we have to divide it by 8 over 3. Okay, so here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After cancelled 3, we found out that st over 2 equals to 6x plus 8 over 8. Here we cross multiply this equation and found out that 8 times st equals to 2 times 6x plus 8. We divided this equation, the first equation, by 2 and found out that 8 over 2 is 4, so in total in this side of the equation we have 4 st. 2 over 2 is 1, so in total in this side of the equation we have 6x plus 8. So 4 st equals to 6x plus 8. We divided this equation by 4 and finally found out that st equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in total we found out that st equals to 1.5x plus 2. Here st equals to 1.5x plus 2. Then continue to focus on this long equation. Those two sides that are equal to each other, so we get the second equation from those two sides that are equal to each other. According to the second equation, we have (2x plus 8 over 3 over 8 over 3 equals to SA plus 8 over SA plus 10 over 3 over 10 over 3. So in this side of the equation we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome factor with 8 over 3. So in this side of the equation we have 3 times 2x is 6x. So in total in the numerator we have 6x plus 8 divided by 3, and we have to divide it by 8 over 3. On the other side of the equation we have SA plus 10 over 3. Here we multiplied SA by 3 and then divided by 3 in order to have a common factor with 10 over 3. So SA times 3 is 3SA. So in total in the numerator of this expression we have 3SA plus 10 divided by 3, and we have to divide it by 10 over 3. So in this side of the equation we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. In the other side of the equation we also have 3 in the numerator and 3 in the denominator, so 3 will cancel. So what is left from this equation 2 after we cancel 3 on both sides of the equation? What is left is it's actually 6x plus 8 over 8 equals to 3SA plus 10 over 10. Here we multiply this equation and found out that 10 times 6x plus 8 equals to 8 times 3SA plus 10. Here we divided this equation by 2 and found out that 8 over 2 is 5. So in total in this side of the equation we have 3 times 6x plus 8, and it is equals to 8 over 2 is 4. So in total in this side of the equation we have 4 times 3SA plus 10. We open the brackets on both sides of this equation 2, and found out that 5 times 6x is 30x, plus 5 times 8 is 40, that equals to 4 times 3SA is 12SA, plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 will get cancelled, and we're left only with 30x, that is equals to 12SA. Here we divided this equation by 12 and finally found out that SA equals to 2.5x. Here this line segment SA equals to 2.5x units in its length. Then I copied the small quadrilateral ABST in a new page with the circle that is described inside it. We analyze this small quadrilateral ASBT. This is the small quadrilateral ASBT that I copied from the original drawing. Here we can implement rule 2. If we focus on the common standpoint point A, we have two tangents to this circle, tangent AK and tangent AN. And according to rule 2, they are equal to each other. That is to say AN equals to AK. According to rule 2, so if AN is A, then AK must be also equal to A because they are equal to each other. So in total we found out that AN equals to AK equals to A. Then we focus on the common standpoint point B. From the common standpoint point B, we have two tangents to this circle, tangent BN and tangent BH, and according to rule 2 they are equal to each other. This is to say BN equals to BH. So if we define the edge is B, then Bn must be also equal to B because they are equal to each other. So in total we found out that Bn equals to Bh equals to B. Then we focus on the common standpoint point T. From the common standpoint point T, we have two tangents to this second, tangent Tg and tangent Th. And according to rule 2, they are equal to each other. That is to say, Th equals to Tg. So if we define Th as C, then Tg must be also equal to C because they are equal to each other. So in conclusion, we found out that Tg equals to Th equals to C. And finally, we focus on the common standpoint point S. From the common standpoint point S, we have two tangents to this second, tangent SC, and tangent SG, and tangent SK. And according to rule 2, they are equal to each other. That is to say, SG equals to SK. So if we define the length of SK as D, then SG must be also equal to D. So in conclusion, we found out that SG equals to SK equals to D. Then we join points, we join side AB to side ST. AB plus ST equals to A plus B plus C plus D. Then we join side AS to the opposite side BT. AS plus BT equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. That is to say, AB plus ST equals to AS plus BT. AB is 2 and ST is 1.5x plus 2. Again, ST is 1.5x plus 2. AS is 2.5x. If AS is 2.5x plus BT. BT is 2x. So BT is 2x. So in conclusion, we found out that 2 plus 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4, so in total in this side of the equation we have 4 plus 1.5x. That is equals to 2.5x plus 2x is 4.5x. So in total we found out that 4 plus 1.5x equals to 4.5x. Here we subtracted 1.5x from this equation and finally found out that 4 equals to 4.5x minus 1.5x is 4x. 4.5x minus 1.5x is 3x. So in total we found out that 4 equals to 3x. We divided this equation by 3 and finally found out that x equals to 4 over 3 units in its length. The radius x of this circle equals to 4 over 3 units in its length. Our mission is to find out the area of this circle. The area of any circle equals to pi times the radius of the circle squared. So in our circle it is pi and the radius is x, so it is pi times x squared. And x equals to 4 over 3. If x is 4 over 3, it means that x squared is 4 over 3 squared. So in total, the area of our circle is pi times 4 over 3 squared. So it is pi and 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in total, we found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 units. Okay, thank you very much.